Hi, for the course 19 MA 206 Logic and Combinatorics, common for the branches CSE and IT. We are in Unit 1, Sets and Functions. This is the second lecture video. In lecture 1, we had already seen what is a relation, okay, what is a domain, what is range, what is codomain, what are composition of functions, what is invertible functions, etc. So this is an extension of the first lecture. So let's get on to the presentation. So again, I repeat the course outcome. Construct the class of functions which transform a finite set into another finite set which relates to input and output functions in computer science. Problem number 1. Let f from R to R be the function defined by f of x is equal to 4x minus 3 for all x in defined in R. Then write f inverse. So it's just a basic part A question. So how am I going to write that f inverse? So to start with, I start with given that f of x is equal to 4x minus 3, which I'm going to say as y. I'm just saying it's y. Then what is happening? 4x minus 3 is equal to y. And in the next step I see 4x is equal to y plus 3. So just taking that 3 to the other side. So now I'm getting the value of x. X is equal to y plus 3 upon 4. So hence, now what is this f inverse? F inverse is just rewriting the given function in terms of y. So therefore f inverse of y is equal to y plus 3 upon 4. So therefore f inverse of x is equal to, replacing it back, replacing x is y. So you'll be getting the final result as x plus 3 divided by 4. So hence the solution. So I'm repeating, first let's take the given function as y and get the value of x, and that x value will be called as f inverse of y because x is nothing but f inverse of y. So f inverse of y is equal to y plus 3 by 4. So finally replacing x is y is x, you get x plus 3 by 4. So the second problem, if f of x is equal to x square plus 6 and g of x is equal to 2x minus 1. So here we have two functions, f of x and g of x. Then find the following. Two things you have to find. Two subdivisions are there. F of g, f composition g of 2 and g composition of f of 3. So solution given f of x is equal to, as always I'll start writing the function f of x is equal to x square plus 6 and g of x is equal to 2x minus 1. And moving on to the first subdivision, so it's going to be f composition g of x, which is, what am I supposed to do here is, how is f composition g of x defined? It's defined as f of g of x. So f of g of x, which means that this g of x function should be substituted in f of x function, which means that this g of x value, what is the g of x value? 2x minus 1. So this you have to treat as your x value and you have to substitute it here in place of the x value which is in f of x. So here in place of this x square, I will be replacing it as 2x minus 1 the whole square. Okay, so 2x minus 1 the whole square plus 2x minus 1 the whole square plus 6. So when I expand this 2x minus 1 the whole square, I use the formula a minus b the whole square formula. A square minus 2ab plus b square and plus 6 combinedly, I'll be getting the answer as 4x square minus 4x plus 7. So this is f composition g of x. So in this f composition g of x, they're asking you to find the value of 2. So in that composition, you have to substitute the x value as 2. So when I'm substituting, it's going to be 2 square, which is going to be 4. 4 into 4 will give you 16. And 4 into 2 will give you 8 plus 7, which is going to be 15. Right. Now next subdivision is g composition f of 3. So before getting on to g composition f of 3, first we should find out what is g composition of f. So g composition of f is, which means this f of x function should be considered as x and that x value should be substituted here in g of x. So here what will I get? G composition f of x is equal to g of f of x. which means x square plus 6 should be substituted here in place of this x, which means that twice of x square plus 6 close the bracket minus 1. So when I'm multiplying, you'll be getting 2x square plus 12 minus 1. So combinedly, you'll be getting 2x square plus 11. In this G composition f of x, you got to substitute 3 because they were asking 3. So when I substitute 3, it's going to be 3 square is 9. 9 into 2 will be giving you 18. 18 plus 11. So your answer is 29. Problem number 3. Now we'll be considering three functions. F, G and H are functions from R to R defined by f of x is equal to x plus 2, g of x is equal to x square plus 3 and h of x is equal to 4x, and then determine the functions. Three subdivisions: G composition F, F composition G of H composition, and F square. So given three functions are here. Now the first subdivisions, G composition of f of x is equal to G of f of x, which is equal to G of this. In place of f of x, you will be having x plus 2. So in place of x plus 2, in the sense here G function is x square plus 3. You will be getting x plus 2 the whole square plus 3. Simplifying, you will be getting your answer as x square plus 4x plus 7. You can just leave it here because they haven't given you any value. And the second subdivision is f composition G of h is equal to, this is how I write it, f of G of h of x, which means that f of G of h of x is 4x. So 4x. So G of 4x. So this 4x will be first substituted in this G of x, which means that it's going to be 16x square plus 16x square plus 3. Now this 16x square plus 3 should be substituted in f of x, which means that 16x square plus 3 plus 2, which gives you 16x square plus 5. And the last subdivision, f square. F square means only f into f, that is f composition itself. So f of x is equal to f of x plus 2. So in x plus 2 again, if I substitute, it's going to be x plus 4. Clear? Problem number 4. If capital A, I have a non-empty set capital A with the numbers 1, 2, 3, 4, 5, 6, and the functions f and g are defined on this particular function. Defined on this particular set as f is 1, 3, 2, 6, 3, 4, 4, 2, 5, 1 and 6, 5, and g is 1, 6, 2, 4, 3, 1, 4, 5, 5, 3, 6, 2. Prove that G composition f of the whole inverse is equal to f inverse composition G inverse. So what are you going to do here? First you write what is f and g. So what are the things required? You have to prove a statement, which means that first you have to find G composition f and then you take the inverse. And here you take separately f inverse and separately G inverse and then take the composition. So first we'll find what is G composition f. G composition f is, how do I find G composition of f? So first I have to start with G because the first function is G. So first you take the first number 1. The first number in G is 1. 1 is mapped to 6. Clear? And go to F. Where is the 6 going? This 6 is mapped to 5. So therefore I will write it as 1, 5. Okay. Next, second brackets 2. Second element. 2 is mapped to 4. Go to 4 in F. Where is this 4 mapped to? 4 is mapped again to 2 itself. So I will be writing 2, 2. Now 3 is mapped to 1 and 1 is mapped to 3. So 3, 3. 4 is mapped to 5 and 5 is mapped to 1. So I'll be writing 4 is mapped to 1. Next, 5 is mapped to 3 and 3 is mapped to 4, which I can write it as 5, 4. 6 is mapped to 2 and 2 is mapped to 6. So it will be writing 6, 6. So therefore, G composition f the whole inverse. This is G composition f. What is G composition of f inverse? The elements, just reversing it. So 1, 5 can be written as 5, 1. 2, 2, 3, 3. 4, 1 is written as 1, 4. 5, 4 is written as 4, 5, 6, 6. Right? This is your left hand side. That's the naming it as equation number 1. Now we have to find F inverse. Very simple, because already F is there. You know what is inverse concept. Just reverse it or swap it. So 1 3 can be swapped as 3 1, 2 6 can be swapped as 6 2, 3 4 can be swapped as 4 3, so on. And G inverse, same way, 1 comma 6 is swapped as 6 1, 2 4 is swapped as 4 2, etc. So therefore, I am getting the composition of F inverse, composition G inverse. How do I start with? The first function is F inverse. So always look at the first function. 3 is mapped to 1. And where is 1 mapped to? 1 is mapped to 3. So 3, 3. 6 is mapped to 2. And 2 is mapped to 6. So 6, 6. 4 is mapped to 3. And 3 is mapped to 5. So 4, comma 5. 2 is mapped to 4. And 4 is mapped to 2. So 2, comma 2. 1 is mapped to 5 and 5 is mapped to 4. So 1 comma 4. 5 is mapped to 6 and 6 is mapped to 1, which is 5 comma 1. This you name it as equation number 2. When you compare equation 1 and 2, they are the same. They are equal. Thus the relation is satisfied. That is G composition F the whole inverse is equal to F inverse composition G inverse. Fifth problem, find the inverse of the following functions. F of x is equal to 1 by root 5 of 2x plus 11, and g of x is equal to 1 plus 2x by 7 plus x. So f of x is equal to fifth root of 2x plus 11. So replacing this f of x is y. So we know why f of x is always equal to y. So y is equal to fifth root of 2x plus 11. So replacing x, swapping x as y, x, and x is equal to fifth root of 2y plus 11. So therefore y is equal to, taking the power 1 by 5. So we'll be getting 1 by 5. So take this is 1 by 5 here. So taking it to the other side, simplifying, you get your f inverse of x. And g of x is equal to 1 plus 2x divided by 7 plus x. So y is equal to 1 plus 2x divided by 7 plus x. Replace x as y and y as x. So replacing it, and replacing y is always given as g inverse of x. So finding that value will be 7x. You will be writing 7x minus 1 by 2 minus x. Thank you.